All right, if you're watching this, it means I couldn't be here today. First thing you're gonna do, take this quiz, and there's directions on the board. You're gonna turn, so once you've turned in the quiz, you should have already done this probably. All of these can be found right there in your notes that we wrote down last time. You're gonna turn them in, and this says metal table, I know, it's not supposed to be metal table, it's metal tray. You're also gonna turn in the test redo stuff in the metal tray, so make sure you put it up there. We're going to go over some problems off of page 409 from the last time. You can either turn it in today, or you can make sure you got it finished and turn it in next class, but that's totally up to you. So if you forget to turn it in next class, then you're just going to be out of luck. So we're going to go over some of them. Make sure you follow along when we go over them. Again, all of these on this quiz you should have been able to find right there in your notes. Right now, what I need you to do, get your books out. Page 409, the assignment from last time. We're going to go over some problems. We're going to do number 1 first, and I'm just going to run through some of these, and we're going to go real quickly. I'm not going to draw them all. This one, they tell us this angle is x, 2x plus 5 up here, x over here, and 2x plus 7 here. This has got 1, 2, 3, 4 sides, so it's a quadrilateral. We know that the 4 interior angles of a quadrilateral have to add up to 360. So we're just going to write out an equation, and if you can collect like terms as you go through and do a bunch of these, it might make everything a little simpler on you. If it doesn't, if you can't, then write it out like I'm doing right here, but some of them I probably won't write out completely. So 2x plus 5, that's this angle, plus the next angle, plus the next angle, plus the last angle here, and all of those add together should add up to a total of 360 because it's a quadrilateral. We collect like terms, 2x, 2x, another x, that's 3x, 5x, 6x. So we've taken care of all the x's. Now we just got to take care of the regular numbers, a 5 and a 7. 5 plus 7 is 12, equals 360. Now we're just going to solve this. Subtract 12 on both sides. 6x equals 348. Make sure you got your calculators out so you can go along with this. Divide 348 on your calculator by 6. And when I divide it on my calculator, I get 58. Some of the problems they asked you to just find x. This problem said to find each angle. So we look back up here. Well, I know that angle's 58 degrees, so that one's pretty easy. I know this angle's 58 degrees because it's just x. For the other two, we plug in 2 times 58 plus 5, and 2 for this in here, 2 times 58 plus 7. Do that on your calculator. 2 times 58 plus 5, I ended up with 121. So that's that angle, 121 degrees. And the other one's just 2 higher than that, so it's 123 degrees. Those are your 4 answers to number 1. And I'm not going to do all these, I'm just doing some of them to try to give you an idea. We'll do a few of them. If I go too quick, you can stop the video and just stop it while I'm trying to hurry through it. Let's jump down to number 5. Or I'm sorry, number 3, sorry. This one, we got a pentagon, 5 sides. So those 5 angles, all the 5 interior angles of a pentagon should add up to 540. That comes from the chart, or you can figure it out using the formulas. And then I look back at the angles there. I'm going to start off. That first angle is x. Then we got a 2x minus 20, so plus 2x minus 20. That's the second angle. Then there's a 90-degree angle. Then there's another 90-degree angle. And and then a 2x plus 10. So this was one angle here, this was one angle, that was one angle, that was one angle, that was one angle. All 5 of those should add up to 540. Again, if you can collect like terms before you write all this out in this long formula or this long equation, then go ahead and do it. Here we got 1x plus 2x, that's 3x, plus another 2x, that's 5x. So we've taken care of the x's. Now we got a 10. I'm going backwards this time because it looks easier to add. A 10 plus a 90, that's 100, plus 190, or plus another 90, that's 190, minus 20, that's 170. So plus 170 equals 540. Subtract 170 on both sides. These cancel out, you're left with 5x equals, that comes out to be 370. Divide both sides by 5. X ends up being 74. Again, they didn't ask us to find x, they asked us to find each angle. This first angle right here was just x, so it's just 74 degrees. The second one would be 2 times 74 minus 20. And for that one, I got 128 degrees when I put it in my calculator. That one was 90. I'm just writing them down to make sure I got all of them. The next one was 90. So that's 4 angles. I'm still missing this one. That's 2 times x is 74 plus 10. And that one come out to be 158 degrees. There's my 5 angles. If you go back and check them, all 5 of those should add up to be 540. Next one, let's do number 6. I probably won't be able to draw this very well. Try to draw the best I can. Something like that. And they tell us this is just part of a regular dodecagon. Well, dodecagon has 12 sides. You can look that up on your chart. And when you look it up on the chart, the interior angles of a dodecagon all add up to, what was it? Oh, I didn't even, we don't even care about that. We could find that, but it doesn't really matter for this problem. So they say it's regular, so we know this angle, this angle, this angle, and this angle are all congruent to each other. And we can find each one of those because we know it is a dodecagon by doing n minus 2 times 180 divided by n, where n is 12 this time. So we're going to do 12 minus 2 times 180 divided by 12. 12 minus 2 is 10. 10 times 180 is 1800. And we divide that by 12. And that tells us that each angle is 150 degrees. So all 4 of these angles are 150 degrees. What happens here when we draw from this center point out to here is it bisects this angle. So it's not 150. Each one of these two isn't 150. It's half of that. So that's 75 degrees and that's 75 degrees. And we're looking for this angle. We go back and we count this. That's 1, 2, 3, 4, 5, 6, 7. This is a 7-sided figure, a heptagon or a septagon. If you look up on your chart, a heptagon or a septagon, all the interior angles should add up to equal 900. Well, we got 150, 150, 150, 150, 75, and 75 plus the x. And I'm going to add these before I write them down. So 150 plus 150 is 300. Another 150 and 150, that's another 300. So that's 600. 75 and 75 together is another 150. We add those two together and that's 750. So all of these angles add up to a total of 750. You can punch them into your calculator and find that out. Plus this last angle, which is x. Well, to find x, which is angle 1, we just subtract 750 on both sides, and we end up with x equals 150. So angle 1 equals 150 degrees. Number 7. Number 7, they say an animal pin is in the shape of a regular heptagon. What is the measure of each interior angle of the animal pin? Round your answer to the nearest 10. So it's a heptagon, so that means it's got 7 sides. And I'm not going to tell you the answer to this one. You can look it up on your chart. You want each interior angle. The measure of each interior angle. Look it up on the chart there. Number 9. Number 9 through 14, sort of the same setup for each one, so I'm just going to do one of them, then we'll skip over them. The measure of an interior angle of a regular polygon is given. Find the measure find the number of sides in the polygon. So the measure of each interior angle. Each interior angle, and the formula for each interior angle from your notes from last time was n minus 2 times 180 divided by n. Well, they're telling us this time that each interior angle equals 144. So we could set up this equation, 144 equals n minus 2 times 180 divided by n. And I'm going to solve that here in a minute. But also I told you that instead of doing each interior angle, a lot of times it's easier to do each exterior angle, deal with the exterior angle formula. And we know if each interior angle is 144 degrees, then to find each exterior angle, we just subtract from 180. So we just take 180 minus 144. Well, that's 36. So the formula for each exterior angle is 360 divided by n, and we know that that has to equal this, which is 36. If I'm solving these, I would rather solve this formula over here than this one, but I'll solve both. If we're going to solve this one, first thing you do, multiply both sides by n. Get rid of the fraction there. So we get 144, n equals n minus 2 times 180. Next thing you got to do is distribute here. You got to distribute this 180 out to both those. So we get 144n equals 180n minus 360. Next thing to do is I'm going to subtract 144n on both sides. And you could do it a different way if you wanted. That leaves me with 0 over here. 36n minus 360 on that side. Then I'm going to add 360 to both sides. And I'm left with 36n equals 360. Divide both sides by 360. And I'm left with n equals 10. So that tells me that the shape has 10 sides. Now, if I use this formula over here, easiest way to do it is make it into a proportion, put a 1 underneath that, and cross multiply. 36 times n is 36n. 360 times 1 is 360. Divide both sides by 36. And you end up with n equals 10. So the shape has 10 sides. Number 15. Jumping down the ways. 15 through 18, sort of the same thing. Main thing to remember on all 4 of those problems is the sum of the exterior angles of any polygon is always 360. Sum of the exterior angles is always 360. And I'm not going to draw this shape. Just looking at it there though, if you go around it, you're just going to add up all the exterior angles. So one of them is x, just going around the shape. The next angle is 2x. Next angle is x plus 10. Ignore that. Next angle is x plus 18. So plus x plus 18 plus the next angle is 3x plus the next angle is x minus 1. And all of those should add up to 360 degrees. No matter how many sides it's got, they're always going to add up 360. Then I'm just going to collect like terms. 1x plus 2x, that's 3x, 4x, 5x, 8x, 9x. So I've taken care of all the x's. Just getting rid of all them so I don't have to look at them. Then I got 10 plus 18, that's 28. Minus a 1, that's 27. So plus 27 equals 360. Subtract 27 on both sides. These cancel out. I'm left with 9x equals, that's 3. Borrowed from there, so that's 333. Divide both sides by 9. And you're left with x equals 37. Grab your calculator and do that. This time they just said just find x. So that's our answer. That's all we have to do. 15 through 18, that's all you do on those. The next bunch, 19 through 24. I'm not going to do any of these. You can do all these. On 19 through 24, several of them you can just use the chart. So use the chart that we made out last time. It just says find the measure of each exterior angle if they're regular. So each exterior angle. They want each exterior angle. Just use your chart, or if it's not on the chart, then use this formula. 360 divided by n, and n is just the number of sides that they tell you in the certain problem. Problem 26 says find the measure of an exterior angle and an interior angle given the number of sides of the regular polygon. Round your answer to the nearest tenth if necessary. So this time they tell us that n equals, on 26, n equals 13. I would find each exterior angle first, because the formula for each exterior angle is 360 divided by n. Well, in this case, n is 13. So you just take 360 divided by 13. And you grab your calculator and you do that, and it doesn't come out all nice and even. When I round it off to nearest tenth, that's one place behind the decimal. That it comes out 27.7 degrees. That's each exterior angle. Now to find each interior angle, we could use the formula n minus 2 times 180 divided by n, and plug in 13 for n on both those and do all that math. Or we could just take this answer and subtract it from 180. And that's probably a little easier. And I come up with 152.3 degrees. That's each interior angle for a 13-sided figure. Those are our two answers. Next one, 28. Reading the problem, it says a convex octagon. Well, if it's an octagon, then we know it's got 8 sides. And you can look up on the chart that the sum of all the interior angles of an octagon is 1080 degrees. That's the sum of all 8 interior angles. And they're telling us all the interior angles here. And we could write out that big long formula. I'll go ahead and do it. So one of the angles, x plus 55. Oh, I'm sorry, I think I just did the wrong. Yeah, no, I'm right. X plus 55, then the next angle is 3x plus 20. The next angle, I'm probably gonna run out of space. 4x, next angle, 4x minus 10. Next angle is 6x minus 55. Next angle is 3x plus 52. Plus the next angle, which is 3x plus the last angle, which is 2x plus 30, and all that should equal 1080. Again, if you can collect like terms without writing it all out like this, it's probably going to be easier. You won't have the silliness like I have here. When I collect all my x's, I come up with 26x. When I collect all my regular numbers, I came up with 92. And all of that should equal 1080. Then just doing the math, I subtract 92 on both sides. You end up with 26x equals, grab your calculator, 1080 minus 92, that equals 1078. Then you divide that answer by 26. Make sure you got a calculator. Sorry, I messed up. This should be, right here should be 988. And then divide that answer by 26. And I end up with x equals 38. Can't see because it's dark and had something on my calculator. Let's see what they ask us to find for problem 28. Just said find the value of x, so that's our answer. We're done with that problem. The rest of those, like 29, 30, those are the same idea. I'm going to do one more. Let's jump over to 36. Or jump down to 36. Problem 36 says the measure of an interior angle of a regular polygon is 24 more than 38 times the measure of each exterior angle. Find the number of sides in the polygon. So each interior, each exterior. They tell us, just reading the problem, that says the measure of each interior angle is 24 more than, well that means 24 plus 38 times the measure of each exterior angle. Well, we don't know how much each exterior angle is. So we're just going to let that be some variable. So I'm going to let each exterior angle be E. So that means 38 times E there. So each interior angle is this, each exterior angle is just E. We know that those two together, each interior angle plus each exterior angle, should add up to equal 180. And I'm just going to take these two things and I'm going to stick them in here in place of this. So each interior angle is 24 plus 38E times E, plus each exterior angle is just E, and that should equal 180. Treat E just like, if you don't like E, put X in there, that's fine. It's just like any other variable. We look at these, that's like a 1E there, so it's 24 plus 39E equals 180. Subtract 24 on both sides. These cancel out. We're left with 39E equals 156. Divide both sides by 39. And you get E equals 4. Now you got to remember what your variable stood for. So we know E stood for each exterior angle. So each exterior angle is 4 degrees. We don't want to know what each exterior angle is. We want to know how many sides the shape has. And we could figure out that each interior angle is 180 minus 4, which is 176 degrees. So we know those two things, but that's not what we're looking for. The formula for each exterior angle is 360 divided by n. Well, we know each exterior angle is 4 degrees. Ignore that. And we know that equals 360 divided by n. If we put a 1 underneath that, we can cross multiply here to make it a little easier on ourselves. 4 times n is just 4n. 1 times 360 is 360. To find n, we divide both sides by 4. If you're ever trying to find n, and n doesn't come out to be a whole number, then there's something wrong. Either you made a mistake in your math, or it's not actually a polygon. 360 divided by 4 is 90. Remember what this means. That means this shape has 90 sides. So there's some of the problems off of the last assignment. I'm going to go over the notes and stuff. Fill in the notes. You can grab the notes from up front off the table. Do that now if you haven't already, so grab the notes and we'll go over them. All right, for parallelograms. What we're going to cover today is parallelograms. Parallelograms are quadrilaterals. Everything that we do for the next few days is going to deal with quadrilaterals, 4-sided figures. There's all kinds of different 4-sided figures that we're going to talk about, just like there was all different kinds of triangles, all different kinds of 3-sided figures, 4-sided figures, same thing. The first one that we're going to deal with, parallelograms. Know and use the properties of parallelograms. You got to be able to prove that a figure is a parallelogram. I'll make a lot of you happy, because that probably means that we might do some 2-column proofs. And do work on a coordinate plane. Got to know the formulas for a coordinate plane: midpoint formula, distance formula. They're on the board over there, and we're going to write them down in these notes also. Fill in what you need to fill in here. Parallelogram is a quadrilateral with both pairs of opposite sides parallel. Remember that these arrows mean that these two are parallel. These two are parallel. Not all 4 sides are parallel. If all 4 sides were parallel, the shape would look like this. That's not possible. So both pairs of opposite sides are parallel. The symbol for a parallelogram, symbol for a triangle, was a little triangle. Parallelogram is the only 4-sided figure that has a symbol. So you're not going to have to remember symbols for all the other 4-sided figures that we cover. Just a parallelogram. Maybe a trapezoid. This book might use a symbol for a trapezoid too, but it just gets too confusing. So parallelogram is probably the only one that we'll use. When you name a parallelogram, it's always got 4 corners, 4 vertices. So when we name it, we put the shape out in front, just like we did with the triangles, and then we go around it in some kind of order. So this one, if I started here and went this direction, I could name it parallelogram A, B, C, D. But you have to go around it in order. You cannot name this parallelogram A, C, B, D. That doesn't work. You can't jump opposite corners or crossways. You could also name it, if you don't like the way I named it, then that's fine. Start somewhere else. Maybe you start with D and you go backwards. D, C, B, A. Many, many different ways to name this parallelogram. Doesn't matter as long as you go around it in some kind of order. Diagonals of a parallelogram. With the diagonals of a parallelogram, just goes from one corner to the opposite corner. Every parallelogram has 2 diagonals. And you might notice something when you look at these diagonals. It looks like, when they cross each other right here, it looks like that B is the midpoint for segment NH. So it looks like that these two segments are congruent, and it looks like these two segments are congruent. And that is true. Now the other thing you got to remember in a parallelogram is if I start walking it in and I walk to H, and you start walking to S and you walk to T, we do not walk the same distance. This diagonal and this diagonal are not the same length. In other four-sided figures, they might be. In a parallelogram, they are not the same length. But these two parts are congruent, these two parts are congruent, and B is always the midpoint of those two diagonals. And some other things you might recognize, this triangle over here and this triangle over here are congruent to each other. This triangle are congruent. If we just drew in one of the diagonals, if I just did that, this triangle and this triangle are always going to be congruent. If I drew in a diagonal going the other direction, this triangle and this triangle are always going to be congruent. You've seen problems like this a couple of chapters ago when we were proving these triangles were congruent. And the reason that we know that these triangles are always congruent is some of the properties we're going to talk about with the parallelogram. These two opposite sides have to be congruent to each other. These two opposite sides have to be congruent to each other. And then they share this side. So anything equals itself. So that means those two triangles are congruent because of side, side, side. So when we draw in the diagonals, or one or both diagonals, it tells us a lot of information in the parallelogram. Area of a parallelogram. The formula for area is 1/2 base times height. If you wanted to change that 1/2 to 0.5, that'd probably be all right. I don't care. It means the same thing. And we'll talk more about the area here in a second. To find the perimeter, you add up all the sides. So if that's side 1, side 2, side 3, side 4, you just add them all up to find the perimeter. This is our parallelogram. These extra marks in here I'm going to explain here in a second. But that's our parallelogram. To find the perimeter, we add them all up. Well, we know 1 and 3 are congruent, so we only really need to know one of those. And we know 2 and 4 are congruent. So if we can find 1 and 4, we add those up and double it, and that's going to give us the whole perimeter. Now, back to area. For area, it's base times height. To find the base and the height of a parallelogram, the height is usually going to be given by some dotted or dashed segment in the parallelogram. It's not actually part of the parallelogram, it's just showing you the height. It goes from the vertex, it's actually an altitude of the parallelogram. It goes from vertex and it goes to the opposite side and it forms a right angle. Sometimes it'll be given outside the parallelogram. So one of the sides is extended out, but that's the height. Or this is the height. They'd be the same thing in this case, but they could give it to you in two different ways there. The base is always the side of the parallelogram, not always the bottom. It's always the side of the parallelogram where that height, where that right angle sits. That's your base. If we were on a graph, and we had this parallelogram on a graph, something like this, we could probably just count to find the height and count to find the base. Now, if it's sitting at an angle, then that makes it a little tougher. The formula, again, for area, 1/2 times base times height. Remember with area, the units are always units squared. And for perimeter, it's always just regular units. Feet, inches, whatever. Properties of a parallelogram. This is probably the most important thing today. You gotta know all these properties. Give you just a second. Fill in what you need to fill in. If for some reason you weren't here last class and you didn't get one of the new books, they're laying on the table to the left in the front of the classroom over by the bookshelf. Make sure it says volume 2 on it. You can grab one of those. All right, so properties of a parallelogram. These are all different properties. If we know a shape, if they tell us that the shape is a parallelogram, then we know all of this is true about every one of these about every one of the shapes. So if it's a parallelogram, opposite sides have to be congruent. So if I have this shape and they tell us it's a parallelogram, those two sides are congruent, those two sides are congruent. If it's a parallelogram, opposite angles have to be congruent. So they give us this shape and tell us it's a parallelogram. That angle has to be congruent to that angle. This angle has to be congruent to that angle. Every single time. If it's a parallelogram, consecutive angles, angles right next to each other, neighbors, have to be supplementary or add up to 180. So if I'm looking back up here at this shape, these two angles have to add up to 180. These two angles have to add up to 180. And it also works with these bottom two angles. They have to add up to 180, or the top two angles have to add up to 180. If it's a parallelogram, we talked about this on one of the other slides here a minute ago, the diagonals bisect each other. So this part and that segment are congruent to each other. That segment and that segment are congruent. Not all four parts are congruent, but each of those two, or each of those pairs are congruent. The one that comes from the definition, opposite sides are parallel. So if we have this, they tell us it's a parallelogram. These two sides are parallel. These two sides are parallel. And then the last thing here, if it's a parallelogram, that means it's a quadrilateral. It's a four-sided figure. So all four angles, 1, 2, 3, and 4, they all got to add up to 360 degrees. You know all those properties. If a shape is a parallelogram, you know all that information. Since I'm not here, we can't really do this, but some things that go around the class and everybody give something about this shape once we know it's a parallelogram. There's all kinds of stuff, and I'm just going to run through a whole bunch of it. If on this shape, we know that this side, if it's a parallelogram, those two sides are congruent. These two sides are congruent. This angle is congruent to that angle. This angle is congruent to that angle. The diagonals bisect each other, so we know that this segment is congruent to this segment. This segment is congruent to that segment. Since it's a parallelogram, we know these two sides are parallel. We know that these two sides are parallel. This is all stuff that we know. Just looking at this shape, we know that these two angles are congruent because they're vertical angles. So that angle is congruent to that angle. We know that this angle and this angle are congruent because they're vertical angles. if this side is parallel to this side, hopefully you remember this, if I draw this, we have that Z, those are alternate interior angles, so that means this angle has to be congruent to this angle. I'm running out of symbols to use here to show that. Well, if those two angles are congruent, then that means this one and this one are also going to be congruent. So let's see, how can I mark this? Let's put two marks with two things going through it. I don't know. Running out of stuff to use. Works going the other direction too. Z there, that means those two angles are congruent. So we'll use that and we'll put a Z on it. This one, Z on it. Then that means this angle and this angle, let's put a X on it, an X on that one. Those two angles are congruent. Other things that we know that this triangle is congruent to this triangle is congruent to this triangle. I'm sure I've missed something there, but you see, if you know it's a parallelogram, a lot of information, tells you a lot of stuff. Ways to prove a shape is a parallelogram. I'll give you a minute. Fill in what you need to fill in on this. So if they just tell us it's a quadrilateral, these are ways, 5 ways that we can prove that it is a parallelogram. You don't have to prove all 5, you just have to prove one of them. So on this, number 1, show both pairs of opposite sides are parallel. So if we can show that these two sides are parallel, these two sides are parallel, then we know for sure it's a parallelogram. If we were on a graph, then that might deal with finding the slopes of each pair of sides. All right, and remember, if you're on a graph, or if we're dealing with that, then slopes same tells us that the lines are parallel. So if their slopes are the same, then those lines have to be parallel. Next one, show both pairs of opposite sides are congruent. So if this side's congruent to this side's congruent to this side, then that tells us that shape has to be a parallelogram. If we're on a graph, that might mean using the distance formula. Find the lengths of each of those sides. Next, show both pairs of opposite angles are congruent. So if this angle is congruent to this angle is congruent to this angle, then the shape has to be a parallelogram. Show the diagonals bisect each other. So if we have this diagonal, we have this diagonal, show that they bisect each other. That means these two are congruent, those two are congruent. That might mean if we were on a graph using the midpoint formula. And all you would do there is find the midpoint of this diagonal, write it down, whatever it happens to be. Find the midpoint of this diagonal, write it down. If those two end up being the same, then we know the shape is a parallelogram. The last one's probably the hardest one. Show one pair of opposite sides are both parallel and congruent. So if we can show that these two sides are parallel and they are congruent, then it's got to be a parallelogram. Now, it's not hard in doing it, it's just hard because it doesn't sort of fit with everything else. If we were on a graph, then you might just look at their slopes, see if the slopes of those two sides are the same. And if we were on a graph and it looked just like this, to find this length and this length, we might be able to just count and show it that way instead of using the distance formula, and that might make it easier. So ways to prove a shape is a parallelogram. All the other stuff that we were covering before this, we knew the shape was a parallelogram and we were using its properties. Now we're saying, all right, we got this quadrilateral, we got this four-sided figure. Is it a parallelogram or not? These are the theorems to prove it's a parallelogram. So if we're doing a two-column proof, you got your statements, you got your reasons. These are the things that would go over here in your reasons column. So if opposite sides are parallel, then it is a parallelogram. If opposite sides are congruent, then it is a parallelogram. So on and so on. These are just the shortened versions that you can write in the reasons column of a two-column proof. I'll give you a second just to get those down. Says the same thing as the last slide, just in a shortened form to make it easier to write as a reason. And not only for a two-column proof, but if it says explain your answer, you say opposite sides are, both pairs of opposite sides are parallel, then I know it's a parallelogram. You just have to write it out that way instead of writing out some big long explanation. If I go too quick through any of this, just have somebody stop the video. Hopefully you know that by now. Couple formulas that you're going to need again, midpoint formula and distance formula. Please don't make the midpoint formula hard. They give you two ordered pairs, whatever they are, 1, 2, 3, 4. And you're trying to remember this is an X, that's a Y, it's a Y. That's an X, that's a Y. All you're doing is plugging in. You're just taking the two X's, adding them together and dividing by 2. That's one of your answers. Taking the two Y's, adding them together and dividing by 2. So in this case, it'd just be, for this midpoint formula, it'd be 1 plus 3 divided by 2. And for the Y's, it would be 2 plus 4 divided by 2. And you should have two separate answers because you're coming up with a point on your coordinate plane, on your coordinate system. 1 plus 3 is 4, 4 divided by 2 is just 2. 2 plus 4 is 6, 6 divided by 2 is 3. The midpoint is going to be that point right there. The distance formula again, and we've covered this many, many times this year. You got your two X's first, you got your two Y's, comes second. Do all of this if you have your calculator like you're supposed to have. You can stick all of that underneath that square root into the calculator just like it is, parentheses and all, and let your calculator do the work. If you need to do it out longhand, so if I was doing these 2 points again, and I need to do it out longhand, I put in my X's. My X's are 1 and 3. I'd probably turn them around, and I'd say 3 minus 1. plus, I put in my y's and I turn them around probably and say 4 minus 2, just so I don't have to deal with negatives. If you're doing it out longhand, don't make this harder than it is. 3 minus 1 is 2. 2 squared is just 4. 4 minus 2 is 2. 2 squared is 4. So now we have 4 plus 4. Well, that equals 8. And then you're going to need your calculator. You're probably going to have to round it off. And you take the square root of 8. But it only takes a couple steps if you're doing it out longhand instead of just punching it all into your calculator. An example, is ABCD a parallelogram? So we're going to graph this, take a second and graph those points. So even if you understand, I've graphed it here, and even if you understand nothing else that I said, if you know how to graph it, and look at it, and make a guess. Is it a parallelogram, is it not? Yes or no? Just at least do something, all right? At least try. Now I look at this, and when I'm looking at it, I'm thinking, man, unless I graphed it wrong, that's probably not a parallelogram. The way I could you can use many different things to check to see if it's a parallelogram. We could look at these two sides, and maybe just look at their slopes, and see if their slopes are the same, and if they're parallel, and maybe look at these two and see if their slopes are the same. We could use distance formula. We could draw in the diagonals and see if the diagonals have the same midpoint. So there's all kinds of stuff. If I'm looking at this, I'm probably looking right here at this side and this side because that looks a little fishy to me. So I'm going to use the distance formula, and those two sides should be the same length. This side, the only reason I'm doing this pair of sides is because this side's a vertical segment and it's easy. All I gotta do is count. 1, 2, 3, 4. So segment AD has a length of 4. That means segment BC should have a length of 4 also. If it doesn't, then it's not a parallelogram. If it does, then we gotta check other things. So I'm gonna use BC here. B and C were these 2 points. That's an X, that's a Y, that's an X, that's a Y, and I'm just going to use the distance formula. Our X's are 4 and 3, so I'm going to do 4 minus 3 squared. Our Y's are 0 and negative 4, so I'm going to do 0 minus a negative 4 squared, and the only reason I do it that way is so I can do the tick or whatever there and make that a plus. I got to do mine out longhand. 4 minus 3 is 1. 1 squared is just 1. Plus 0 plus 4 is 4. 4 squared is 16. I add those together and I get the square root of 17. Now I'm going to grab my calculator and I'm going to do square root of 17 and I get 4.12 something. I look at, so that's the length of segment BC. So that's that. AD was this. Those two to explain this. Opposite. Sides. Not equal. So it is not a parallelogram. Just write it out and explain it. We don't have to check anything else. We could, we could have started with these two sides and seen if they were the same length. A little more work. But we don't have to check anything else because once this doesn't work, then it can't be a parallelogram. If it did work, then we'd have to go back and check how long segment AB is and how long segment AC is and see if they were the same. Find all possible, so we want to find everything that we possibly can in this problem here. given that it is a parallelogram. So the first thing I'm going to look for is I want to find x. And I know if this is a parallelogram, then these two, the diagonals bisect each other, so those two should be the same. So 5x minus 10 should equal 2x plus 2. Subtract 2x on both sides. Remember, diagonals have to bisect each other if it is a parallelogram, and they told us it was a parallelogram. So 3x minus 10 equals 2. Add 10 to both sides. And I end up with 3x equals 12. Divide both sides by 3. And I end up with x equals 4. So if x is 4, now I'm going to plug that in. If x is 4, 4 plus 3 right here, that's 7. Well, BH is 7, then that means NH has to be 7. So I'm going to write that in there. I can plug in 4 right here. 2 times 4 is 8. 8 plus 2 is 10. So this part has to be, that segment has to be 10. Well, then that means this segment has to be 10. I also have an x right up here. I can plug in there. 10 times 4 is 40. So that angle right there is 40 degrees. 20 times 4 is 80. That angle is 80 degrees. This whole thing is 120 degrees, just adding them together. Well, that means that this whole angle down here has to be 120 degrees. And we can also look, we got the z right here. If this angle's 40, then that means this angle has to be 40. And it works the other way around for this one too. That means that has to be 80. We can use the z or the n like this. So if this angle is 48, they told us that. That means this angle over here has to be 48. The other thing that we know that angle T up here, this whole thing, and this bottom angle, these consecutive angles, they have to add up to 180. Well, if this whole thing down here is 120, then that means this whole angle up here has to be 60. 180 minus 120. Well, this part's 48, so all we do is take 60 minus 48, and that gives us 12. That means this top part right here that we don't know is 12 degrees. And then the same thing down here in this corner, it has to be 12 degrees. Some easy stuff that we haven't done yet. If this top part is 13, then this bottom part down here has to be 13, that segment. If this side over here is 8, then this side on the opposite side has to be 8. Some other stuff that we can still say. We have a triangle down here on the bottom. And we know that this angle is 12 degrees. We know that this angle is 40 degrees. That's 52. 3 angles of a triangle got to add up to 180. So 180 minus 52, that's 8. Borrow, that's 7, that's 2, that's 128. So this angle right here has got to be 128 degrees. These are vertical angles, so it has to be 128 degrees. These two angles have to add up to 180. Well, we just got done doing that down here. So this angle has to be 52 degrees, and this angle over here has to be 52 degrees. There's all kinds of other stuff that we can say, but as far as measurements go, that's about all we can find. The assignments on these 2 separate pages. If I'm here, we would do some together. Probably not going to do them on the video. That's what you should be working on for the last few minutes of class. Again, make sure Your test redo and the quiz are in the metal tray, and assignment 409 you can put in the metal tray now, or you can save it till next time.